All right, a couple things to talk about this week. First, nuts and bolts. I always end up wasting money on nuts and bolts on projects because I end up getting the wrong size or the wrong thread or something just not being right. The local hardware store doesn't take returns on individual bolt and nut purchases, so I end up just being stuck with them. In this case, I ordered these from Master Macar based on a bill of materials from the Baddeley R2D2 Facebook group. These are M4 square nuts. I ordered 50. I'm getting to the point where I can start putting some pieces together, if not to be glued, because they use glue and or nuts and bolts, or because I can check fitment by assembling them with nuts and bolts, making sure things fit right, and then taking them apart later. So I got out the nuts and bolts that I bought from Master Macar. I had ripped the package open and put them into a baggie with a Ziploc, just so they'd be easier to handle instead of when you order them from Master Macar, they come in just a sealed plastic bag. So once you open that, they're going to fall all over the floor if you don't put them into something like this or fold and tape over the edge of the bag. I realized that the feet use somewhere over 20 of these per foot drive. So here's 50. That's just enough to do the 2 foot drives and leave practically nothing else. And these M4 square nuts are used all over R2D2 for holding different things together. So I knew I needed to get more, so I went on Amazon, and these came from Amazon. This is 100 M4 square nuts. Same thing, these came from originally China, just in a sealed plastic bag. So again, I just found a spare bag with a Ziploc top that I could put them into. So it's not like I can easily return these. I also tend to, if I order something wrong, but there's nothing wrong with the item, I just am the type of person that tends not to return it because it was my mistake, especially if it's something that doesn't cost all that much. Just, I don't know, guilty conscience, whatever. So, here's an example where I bought a whole bunch of nuts and I started putting things together this week. And so here's one of the pieces. Now this is one of the pieces that goes onto the center ankle. And it's 2 pieces that go together, and then they bolt into the center ankle, which the center ankle itself for the Mark III version is 2 parts that glue and bolt together also. So very nice assembly. You can see my part. They fit in really nicely. The silver one was printed on my Prusa printer with the silver Prusa filament. And the white ones were printed on my T-Vor Tornado in eSun PLA Plus white filament. These haven't been sanded down at all. They have rough edges and obviously aren't smooth and ready for paint or anything. But again, it's like, okay, let me try and put them together, maybe bolt them together, and then I can do some sanding. And I know I need to do some filling of the seams because I seem to get warping around the edges of my prints. So the middle part of this is stuck together really well, but along the edges it just tends to warp even with a brim. I print everything on that T-Vor Tornado with a brim, and yet still the edges lift up. The brim does not, but the edges do. It's really weird, but shouldn't be a big deal. But back to the whole square nut thing. Okay, so this piece uses square nuts in 2 different places. Okay, right here you can see there's this opening. You drop a square nut in, and then it should slide down. That opening goes all the way down to here, so the square nut lines up with this hole. And then this top piece goes on top, and you use a countersunk screw to go into that hole and screw into the nut. So that way you can assemble this if you wanted to without any glue, by having one on each side, bolts holding it together. Or you could do what I was going to do, glue and the bolts, just to make it really secure. Or you can not do bolts and just do glue. It's really up to you. It also has these small holes, which are alignment pegs for filament, 1.75 millimeter filament on both sides to line it up and glue it together. In fact, that's how the outer feet work for this same piece. There's two of these on the center ankle, but there's only one of these on the outer feet, and they do not have this attachment method. So this center ankle is a totally new design as compared to the version 2 droid. This is from the Mark III droid. So that one I just used glue to glue the two halves together. But as I'm saying, this one shows a good example of a piece that uses M4 square nuts. Now you'll notice that nut is not sliding down. Why is that nut not sliding down? Well, it's just a little too thick to slide down that slot. Now, I don't know if this camera's going to pick it up, but that opening does go all the way down, like I said, so the nut should slide down, but it's just too thick. And so I did that, and I'm like, what's going on? Because, I haven't had any problems with accuracy with this Prusa printer. So how come suddenly it doesn't fit and slide down that hole? So it fits really nice into this. I believe I printed these in this orientation on the print bed. So this would be X, this would be Y, and Z would be the height. So that would tell me that maybe my Z height is off calibration. That my Z height should have been higher, so when it's printing this piece, that hole would just be a little bit deeper. It's just a little bit too small for that nut to slide down there. Well, how do I fix that? Well, I can't really file in there because it goes in at an angle all the way down. So at that point, I was stymied. I'm like, okay, I don't get this. I'm not sure what's going on. Let me look at the top part of this. Okay, the top part of this also uses M4 nuts. It goes into here, into this ankle piece, and then inside the ankle piece, you can see those two holes. Again, countersunk bolts go up there and into those square openings. So I took my square nut. And I'm like, okay, well, let's put a square nut in there. And I found, well, it's kind of going, but then it just kind of stops and it's bowing the plastic out a little bit on the sides. And I'm like, well, wait a minute now. This piece here, because it was printed in this orientation, if there wasn't enough depth for the screw, that would be a Z calibration issue. It's not printing tall enough on the Z axis. This was printed like that, so this would mean the x-axis is not printing wide enough, so my x-axis is off. So at that point I'm like, hang on, why would the x-axis be off, the z-axis be off on my Prusa, and yet the square nut fits in this piece, which was printed at the same time this one. They were both printed side by side like that. I think I did either these two together, or because there's one for each side of the ankle, I might have done two of each of these together. I think I did all four at the same time. So how is this one off on the x-axis, but the nut fits in here on the x-axis? So something else is going on. So I took the ankle, and again, you can see on that side, square nut. That side it's recessed for a bolt. So you take the square nut and you put it in there and it fits perfectly. So I'm like, okay, well, is my TiVo adjusted properly and the Prusa isn't? But then that fits in there and there's not a lot of slop, so I don't think that it's that. So then I went to the Facebook group, and that's when I found out that not all M4 square nuts are created equal. This is not mentioned in the instructions that I saw. The instructions, I was specifically looking at the instructions for the feet, outer feet drives, not the center ankle, but the outer feet, assembling the drive units, and it just says you need however many it is. I think it's like 23 M4 square nuts. So these from Master Macar I got from, again, I got the part number from a bill of material that's been posted to the MrBaddley Facebook group in the files section. Somebody posted what they ordered from Master Macar to get most, if not all, of the hardware for the R2D2 build. And so I took that directly from Master Macar. So I'm thinking the M3 build might be a little bit different than the MK3 build might be a little bit different than the version 2 build. It might use more square nuts of the other variety that I'll get to in just a sec than the version 2 does, because if somebody posted their bill of materials that this is what they ordered and they didn't say they had a problem with them, then how come I'm having a problem? Well, the first thing I'm trying to do is from the Mark III R2D2 files, not the version 2 R2D2 files, so that might be part of the reason. But let's get into why. Now, again, hopefully this phone, you're going to be able to see, which is my cell phone here. There we have side by side the black anodized bolts that came from Master Macar and the silver bolts that came from Amazon. You'll see the top and the bottom. And you'll see that this side here, I'll just call it the bottom. I don't know if there's technically there is a top and a bottom, but this side here is perfectly flat. So perfectly flat on the top. This, which I'll call the top of the bolt, there's a crown to it. If you can see, the ones on the left are flat on the top, and the ones on the right, same bolts, just flipped upside down, have a crown on the top. A little slightly raised area. So I went to the Facebook group, and I found out that once I started looking on the Facebook group, searching for, all I did is type in M4 square nut. And I found all kinds of posts that said, oh yeah, make sure you get the 2mm high version. Oh, okay, well that's not in the instructions. It just says M4 square nuts. So I looked and I found more and more posts that said, yeah, I can't get the M4 nuts in, what should I do? And if you heat it up, you can, if you have something like this, if you actually heat the bolt up, it'll kind of melt its way in as you push it in and it'll go in. And then people say, yeah, but get the M4 flat nuts and you shouldn't have to worry about that. And I'm like, M4 by 2. These are, okay, they're M4 nuts, metric nuts, and they're 7mm on each of the 4 sides. And these evidently are 3mm high, and the flat M4 nuts are 2mm high. But I don't think they're advertised as M4 flat nuts. They're just M4 square nuts, and you have to pay attention whether they are 3mm high or 2mm high, whether they are the same flat texture on both sides, or if they're like this where they have that one side that's kind of raised up like a standard normal nut that you use every day is, where it's kind of flatter on one side and tends to be raised on the other. So now knowing that, I just went to Amazon and ordered the M4 nuts that are 2 millimeters high, because I don't want to mess with melting parts, heating bolts, heating nuts, whatever. I don't want to mess with that. Filing holes to make them wider. I just want the things to fit. I don't want to mess with it. So now I've got 50 of these from Master Macar, 100 of these from Amazon, and I just ordered, because I'm not a member of Amazon Prime, I just ordered 4 packs of 50 of the M4 that are 2 millimeters high from Amazon, so I could get the free shipping, because basically the free shipping is like the same price as one bag. So if I had is like the bags are like $7 and I think 16 cents for 50, I think. So if I had bought 3 of them and paid shipping, it would have been about the same price as if I bought 4 and then got the free standard delivery shipping for buying over $25 on Amazon. So now I'm going to have way more than enough bolts to finish. And I will be using, maybe not all of these, but I will be using a lot of these. Where I can, I will use them. And this is a perfect example where the nut fits in there and is completely recessed. It's not even flush with the surface. So there's no reason I can't use one of these longer nuts in there. I'll try and, like right there, I can see it dropped in where the flat part is facing up. I will definitely try to get the flat part facing down where I use them, so it's got even pressure against the plastic all the way around, so it's got the flat surface facing down. But in an application like that, you can see how far down in that hole that is. That doesn't matter if it's one of these 3 millimeter high nuts or a 2 millimeter high nut. That has no effect on that. But anything like this, where it's slotting in, or like this, where it drops in fine because the outer dimensions are fine, but it won't slide down that opening because it's too high, then I'll have to use the 2 millimeter high nuts. And so, I mean, there's an example where that piece right there takes 4 of those square nuts. This takes 1 of the square nut. If you look inside, because this ankle is 2 pieces that are glued and bolted together, there's 2 more square nuts. And again, those can be the 3 millimeter high ones without a problem. So I know I ordered way too many of the 2 millimeter high ones, but I was just kind of like, why is this not in the instructions? Why doesn't it say 4 M square nuts, 7 millimeter by 7 millimeter by 2 millimeter? Because that would have right there saved me if I saw that in the instructions. But there are so many square nuts used in the assembly of this that I should be able to use. I'm guessing I'll be able to use these 50 probably. Although again, black on something that's going to end up painted white, even though I don't think you see that. I think that's right between the fact that it's right down there at the point where the ankle meets the foot. You don't really see that, but I think I'll make that one of the chrome ones because that's a little bit less obvious than a black nut on a white printed part. So yeah, I'll obviously be using some of both of these bags, as well as the ones that I ordered, the proper 2 millimeter wide or tall, however you want to put that. So, yeah, just something to watch out for. I had no idea because, like I said, the instructions just call for M4 square nuts. Part of that, I think, is that I'm in the US and Michael Baddeley, who designed this, is in the UK. And I'm thinking in the UK, perhaps M4 square nuts tend to be 2 millimeter tall, and maybe the 3 millimeter are not that common. Whereas here, what I ordered in the States off Amazon and Master Macar, they just happen to be the 3 millimeter. But just changing that in the instructions would help other people, so that's why I'm making this video, so you guys can see if you're making an R2D2, especially the MK3 version of R2D2, make sure you get M4 square nuts that are only 2 millimeters high. If they don't say, take a look at the pictures, and if the picture shows some of them that look like that on one side, they've got that crown, that height, extra bit of height, then don't get those. You don't want those. You're better off just getting the 2 millimeter ones because it's not going to hurt anything if you get 2 millimeter. But if you get these 3, like I said, you'll be able to use them in some places but not others. So that's it about nuts today. I have one more thing to talk about, and that is this. This is the first thing I've ever printed in flex filament, and it printed. I'm really shocked. It had some stringing. I thought I turned retraction off, but I can actually see my extruder backing up and going forward, so it is retracting the filament. So it had some stringing I had to clear up, and some of it was thin stringing, and some of it was thicker. I printed this at a 0.2 resolution, so I think some of it was that thick. But between using my fingernails and a razor blade or hobby knife, I got 99% of all that off. This is also semi-interesting because the build instructions say to use TPU filament, which is what this is, and it doesn't say which TPU filament or which hardness, which I think is a little bit annoying. I went online, and having never printed 3D filament, never bought it before, I was shocked because the premier, I'll call it the premier brand of flexible filament, is called, produced by a company called Ninja Tech. And they make several different flexible filaments, and some are more flexible than others. So they tend to rate the hardness on something called the Shore scale. So you've got the Shore rating, and I believe the higher the Shore rating, the less flexible it is, the more stiff it is. So if you can imagine it, just a spool of filament PLA, if you pull on it, nothing's going to happen. You're going to break it. Whereas this stuff, you pull on it, and it's like a rubber band. But evidently it's plastic and not rubber. So, at first I thought, okay, well, I'll get Ninja Flex, made by Ninja Tech, because that seems to be the one that people get, and I'll print this tire out of it. So I go to Amazon, and I find that the Ninja Tech filaments are way expensive. A 1 kilogram spool of Ninja Tech filament, I believe, was $55. So I saw that, and I'm like, whoa, that's crazy. I don't need a full spool. I've never printed flex filament before. I don't know how much flex filament I'm gonna be printing, but I shouldn't need 1,000 grams. So they have half spools. Well, the half spools are $20-something for a half spool. So at that point, I decided, well, let me look at other brands. So I looked at the Overture brand, on Amazon, and a 1,000 gram spool of Overture TPU, which is what this is, Blue Overture TPU, was, I believe it was like $22. So basically for, I think it was a little bit less than half a spool of Ninja Tech flexible filament, I could get an entire 1,000 grams, twice the filament, for a slightly smaller price than 500, half the size of Ninja Tech. So I did a little more research on the forums, and of course Ninja Tech, the company, makes a filament called Ninja Flex, and then they also make one called Cheetah, and I think they might make some others, but those are the two main ones that I saw on the Facebook forums. Ninja Tech, Ninja Flex, and Cheetah. So looking at what you use this for, you use this for the omni wheels, which are the wheels that go under the feet so that R2D2 can roll. And omni wheels are wheels that roll forward and back and can roll side to side any direction. So they're not like this. I should have brought one out because I just ordered some from Vex Robotics instead of building my own. If you're going to build your own, you have to build all these little tiny wheels, oblong, almost football shaped, well, US football, not soccer, sorry. Oblong wheels. You have to print just tons of them. I think it's somewhere around 40 of them. And then, so there's a center hub that goes around to go forward and back, and then these little wheels are mounted on it so they can go sideways. So that allows the wheel to smoothly move in any direction. Well, evidently TPU is hard to print, hard to get for a lot of people to print right. And it takes forever to print all those little wheels. And then when you have those little wheels, you have to put PETG or ABS is what they recommend, axle basically through the middle, and people have to like warm them up in boiling water and use a vise to squeeze them together, and it's like, okay, that's too much work. And I think now that there is an option that you can purchase, I thought I'd go with that. So there's a company called Vex Robotics that makes omni wheels, and so you basically can store buy your omni wheels so you don't have to print any of that in flexible filament. Also, there's a whole hub that has to be printed in PETG recommended, and then all those little wheels go in it, and then you cut 12 millimeter long pieces of 3 millimeter diameter metal shaft. It's just it's really time consuming, takes a lot of parts. So a lot of people opt now to buy the Vex wheels, Vex Robotics Omni wheels, and then there are drive units that have been modified to use those instead of the ones that you make yourself. So that's what I did. So I didn't have to print any of those little oblong wheels that go all around the tire, the wheel structure for the Omni wheels. But I did still have to print this for the main drive tire. So this goes one of these in each, the left and the right foot. There's a PETG wheel that fits inside this, and then gearing that drives it from the scooter motors. So I got online and people were saying you can use Ninja Tech brand Cheetah filament to print both the tire and all those little oblong omni wheels. So I looked at the Cheetah hardness, and it is rated at a 95A shore hardness. So then I looked at this Overture TPU, and it is rated at 95A shore hardness. So I thought, okay, it's the same hardness as the NinjaFlex Cheetah. It's a little bit less than half the price. I didn't see that I could buy it in a half a spool, but the full spool is a little bit less than the half spool of the Cheetah filament, so I'll buy that. And instead of buying black, which to print tires you first thought is probably black tires, because that's what cars always have, black tires, I decided to get blue. Blue fits in with R2D2 since he's blue and white. And also, I have a whole spool of it, so anything else I ever print in that flexible filament, I'd rather, have something that prints in a nice looking, blue color than black. So that's why I got the blue. So I got that, and then I had to figure out how much infill to print. Obviously, just like a plastic part, the more infill, the stronger that part's going to be. Like these ankles are, I believe I did these on 40% infill, because they take the weight of the droid on them, goes through these ankles and then down into the feet. So they have to be strong. Whereas the body panels, I think I maybe did it 25% infill. These, I think I did at 15, because they're just decorative things that hang off. They don't have to be strong. They don't support any weight whatsoever but their own. So you don't have to waste a bunch of plastic making a really solid, thick, solid infill to make them super strong, because they don't need to be strong. So people were suggesting 50% infill and 5 perimeters for Cheetah Flex to print the wheels, and that's where it gets a little bit confusing, because you've got those oblong omni wheels that you need like 40 of, and then you've got these that you need 2 of. So when I sliced these, brought these into my Prusa slicer program, I made them 50% infill. Did a cubic infill pattern. So these they flex, but they are fairly stiff. But I think they're going to be fine. So why I'm mentioning this is later on I'm doing more research, and eventually you find where there's comments about, printing them at 5 perimeters and 50% infill, but they might have been talking about the Ninja Flex filament and not Cheetah. The Ninja Flex filament, I believe, is 85%, 85A hardness, 85A shore hardness. So it's a more rubbery, it's a more flexible material than the Cheetah. And therefore this Overture TPU, which is a 95A. The Ninja Flex is, I believe, an 85A. So it's got more bounce, more stretch to it. So I'm thinking that I should have done these in 35% infill. And where I was reading that people were printing with 50% infill, it was those small omni wheels and not these main drive units. I know that it's not really going to matter for me, because my droid is not going to be driven that much. In fact, now that I have crossed the $1,000 mark on what I've spent on this droid, I'm almost thinking of not making it fully drivable. Although I'll probably just be putting it off is what I'll do, because I've spent enough money now and I have enough parts and stuff that apart from primer and filler and paint, I can get the thing assembled for the most part without spending too much more money at this point. I hope. Knock on wood. So one thing I could do is print another set of these at 35% infill, just because, again, what else am I going to print in flexible filament? People print phone cases in it. Well, I'm fine with the phone case on my phone. I don't feel the need to print a phone case. There are some servo attachments for R2D2 that are recommended to print in the flexible filament, because when the servo is moving, say a door or something, and it might extend past its reach, if you've got slightly flexible filament, that helps it not damage the servo. So I've got some of that stuff to print, but those are all small things, and there's not that many of them. So it wouldn't really hurt me at all. And I've already done it. I've already sliced another wheel with 35% instead of 50. It only took about an hour off of the print time. This was 10 hours and 40 minutes, I believe. 0.2 resolution with 50% cubic infill, 5 perimeters. So that's the story on this. It's just kind of a... From what I gather, if the rubber's too hard, it might have difficulty on certain surfaces, and likewise if it's too soft. So I can't remember if a harder wheel handles carpet worse than a soft wheel, or vice versa, or if a harder wheel handles hard surfaces better or worse than a softer wheel. I'm not sure, but I know they're flexible. They're going to be fine. It's going to be a pain in the neck getting this on the wheel, the plastic wheel. What people generally do, it looks like they either put it in the oven for a while to warm it up, or they boil water and then they put it in the boiling water for a few minutes, and that softens it up just enough where they can pop it onto the rim, the plastic wheel. So I haven't got the plastic wheel out yet to even try putting this on top of it yet. Just finished printing it this morning and pulling off all the stringing that I could till it's fairly smooth on the inside. So that was it for today. Again, every video I think is going to be short, and I just blabber on. It gets longer and longer, but something I had no idea about until today when I started putting this stuff together, that M4 square nuts come in different heights. So you're better off just making sure you get M4 nuts that are 7mm by 7mm by 2mm thick. And then likewise, if you're getting a flexible filament, if money's no object, then get the Ninja Tech brand. But this half-price Overture TPU seems to have printed fine. I'm very surprised that this printed on the first try. I still cannot get PETG to print if it's more than a couple hours long of a print. It warps off the bed, whether I use helper discs, brims, blue tape on top of the helper discs, and brims to hold it down. I still have issues printing PETG. It drives me nuts. But this TPU, I used the Prusa Slicer default, I think it's Sane Smart TPU. That's another brand that makes TPU, Sane Smart. So there's a default Sane Smart TPU setting in Prusa. And I think I went in there and I think I lowered the speed a little bit on it. And I thought I turned retraction off, but like I said, it's still retracting. I can see the extruder actually reversing, so it is pulling filament back up when it does some of the moves. So that's evidently whatever I turned off didn't really turn it off, but it still worked good enough that it just took a little bit of cleaning of the strings. I guess people use like heat gun to kind of melt the strings, but like I said, some of them aren't thin wispy strings. They were thicker strings, and I wasn't sure if they would take care of those too, so I just experimented with my thumbnail and a hobby knife and got them out to the string off to the point where this will go on the rim and fit nice and flush just fine. So yeah, that's the two topics I wanted to cover for this week. All right, I'm gonna post two videos. I briefly talked about the wheel that the flex filament goes on, so I thought I'd bring that out here. You can see that it's, hopefully you can see, it's got raised, these areas are flush all the way across, and it's got these recessed areas. And then the tire has the same thing, or opposite thing. So these raised areas in the tire go into the recessed areas in the wheel. And yeah, you can see how that might be a pain in the neck to put on without warming up the tire to make it flexible enough to fit over that easier. And the reason, of course, you want to do that is the last thing you want is the tire spinning on the wheel. The wheel is driven by the motor. There's a gear that goes on one side of it that hooks up to some other gears that hook up to the scooter motor. So that drives this. Well, if you didn't have these areas locking the tire into that wheel, then what you might end up with is the weight of the droid keeps the tire in one place and the wheel just spins inside the tire. So that's why it's got this really nice design with the recessed areas there that line up with the tire. So that's that assembly. This is the drive unit. These pieces are all PETG. I wasted at least half a spool. This piece here should be strong enough, but not happy with the first layer there. Just have a heck of a time with printing PETG on my Prusa for some reason. To make this drive system work with the purchased Omni wheels, there's a modification, and it basically just consists of a few parts. These parts work with the purchased Omni wheels and replace these versions that are made if you make your own Omni wheels. And then there's also a plastic hex piece washer in there. In fact, I think there's two. If there's not two, then I might need to print another one. So I originally was going to build my own wheels because I believe it's less expensive, but then looking at the amount of work involved and the fact that I have some issues with PETG and I'm almost out of PETG, I'd have to buy another spool of PETG to do it. So I decided to just go ahead and purchase the Omni wheels. So that's what this is. I was talking about it in the last video. Hard to describe. This is an Omni wheel. Called that because not only will it drive forward and back, it drives side to side, so it goes in any direction. Now you're saying, well, that Doesn't sound right, Tom. That's making a bunch of noise. That's because you put bearings in here. So it actually rolls. These two directions are the bearing spinning, and then the left and right are these rubbery type wheels. So in the end, when it's all put together, it's really quiet and smooth in any direction. This is a 4-inch omni wheel from Vex Robotics. It looks like 2, but this is called 1 omni wheel. These 2 pieces already assembled together. For the Mark III omni wheel modification, it uses 2 4-inch in the front of the center ankle and 2 in the rear of the center ankle, or center foot, sorry. And then the outer drive wheels use 3.5-inch Vex wheels and only 1. So you end up purchasing 4 of these 4-inch and then 2 of the 3.5. One that goes on the right foot and one that goes on the left foot. So again, if you look at this, the reason why these are pricey, I mean, there's quite a bit involved here, and you have to print these. If you don't buy them, you're printing this. So the black parts here are plastic, so you got to print plastic piece there, plastic piece there, there, and there. So there's 4 plastic pieces here that need to be printed. And then in between the 2 plastic pieces, there's a metal rod that goes through this wheel, all of these wheels. So there's 1, 2, 3, 4, 5, 6 on the Vex. I'm not sure if the Omni wheels also have 6, or if they have more or less, to be honest, because I chose not to print those. But that's, so this one assembly here, there's 4 pieces that should be printed in PETG. There's 12 of these wheels that should be printed in flex material. There's 12 metal rods that go through these that need to be hand cut down to the proper size. I believe the Mark III design uses bearings in each of these rubber wheels, bearings in the front and back, and I believe a plastic core that goes through it. So you can see there's a lot of parts that need to be printed and assembled to make these work. And I decided just to buy them instead. Now, it was sticker shock. I believe I got everything I needed from Vex Robotics to do the 2 outer wheels and the center wheels, the 2 outer feet and the center feet, and it was just over $200. So that was a big, yeah, that was a big cash layout, considering everything else in the droid. Even Filament, you can buy a spool at a time if you want or whatever. But $200 on wheel parts and bearings, basically, it's just like, that hurt. That's a lot of money, but I just didn't want to deal with buying another roll of PETG and printing all these things and then sourcing the metal rods and then cutting them all with a Dremel or a hacksaw or whatever to get them just the right width and printing all these in TPU. And yeah, so that's why a lot of people now are buying these and using the modified files that let you use these on the droids. So yeah, a full spool would have been enough to print all of those that are needed for both the two tires for the outer wheels and all of these for the inner wheels. I'm sure a half a spool would have. I think this was just over 100 grams. And if I had printed it at 35%, I think that came in at 80 something, somewhere around 85 grams of filament. And so, yeah, a half spool is 500 grams of filament if you bought the more expensive Ninja Tech brand. There's something like $25 for 500 grams of filament. This Overture TPU is like $22 for 1,000 grams, which is why I bought it, as I said in the earlier video. But yeah, so just trying to explain what those are, and this is what these are. All pre-assembled units, and then you just have to, you put bearings in here, and from Vex Robotics you also buy a spacer that goes in between for the center wheel, in between the two, because it uses two of these side by side, and then washer and just a standard bolt from the hardware store as an axle that goes through the bearings that are in the middle, and then bolts to the assembly that's printed out in here. Well, actually, this is the outer drives. I've got a different tub that's got the assembly that this bolts to for the center foot. So yeah, that's second video today. This one is just kind of showing you what a Vex wheel, Vex Robotics Omni wheel looks like, or this just called just Omni wheels if you look for them on the MrBaddley printed files. If you're going to print your own, they're just called Omni wheels, and just showing you what you're paying for if you decide to buy them instead of making your own. The amount of time you're saving. Again, if one of these breaks though, and you made these yourself, and say one of these wheels snaps off, you'd be able to just print, you know, whatever caused it to break, print those parts, take it apart, and then put it back together. Whereas if this part of this breaks on my build, I have to buy, you know, this whole assembly for I think these are like $20. So maybe if you're going to be using yours a ton, maybe it makes more sense to build it yourself. Maybe it makes more sense price-wise, although I could not find a post. I found posts of people saying, hey, does anybody actually have the price comparison between Vex and do-it-yourself? And nobody really came up with a detailed, here's what all the parts are for the Vex, and here's what all the parts are for the build-it-yourself. Like I said, my Vex order was, I think it was just over $200, which includes shipping, which I believe was about $20 in itself. So about $200 there. I've spent $6 at the hardware store with the getting 2 axle bolts for the center foot assembly, because again it uses 2 of these mounted front, 2 of these mounted in the back, all covered by the foot. So about $6 on hardware from the hardware store. But then I still have I believe some hardware store bits for the drive wheels, for that use the one of these 3.5 inch on each side. I think I need like just to buy a bolt and a few washers for that too. So I estimate somewhere around $220 or something for the whole Vex setup, compared to how much it costs to build yourself. That I would say you're going to use. You're going to be using your PETG filament, you're going to be using your TPU filament, you're going to be ordering the bar stock, you're going to be cutting the bar stock, and I can't remember if they're held together with bolts on the do-it-yourself or not, but yeah. Anyway, so that was the second video, just to show you, instead of just talking about what an Omni wheel is, to show you what an Omni wheel is. And to show you, I guess, the parts for the outer wheel, outer drive assembly. You can see some of the gears in there, and how this tire is going to eventually go onto this wheel.